So are there any direct questions about online surveys or online questionnaires? Because if you have a very specific question, no matter, there are no stupid questions, any you can ask anything. If you have, you can ask it. If not, I wanted to show you a little bit about setting up an online experiment. So you tell me, are there right now any no direct questions, right? No? Okay. So let me now, if it is too small on the screen, by the way, if something is too small, just let me know, because then I can zoom in. Just also need to just quickly. Oh yeah, good idea. Good. Right. Okay. So let me zoom in a little bit so that you can read it. Can you read it all in the back? So can you read? I don't know how. Oh, well, you probably did. Oh, yeah. It is actually quite big. Yeah. Good. It's even, you don't even see everything, I noticed. Right. Okay. But do you see here, right? All right. Okay. So it is. My screen is a little bit bigger. Right, okay, so now when you set up a new account, so what you get is an example experiment, right? Now, if you click the experiment, let me see, whether you can see the right? Yeah, good. So I said this before, you see this code, and I would like to explain a few things about this code. Well, I have put a lot of effort in making sure that you can find all information that you would need to solve your problem. It's all online. And there are many, especially examples, because with writing scripts, often the best way to learn how to write a script is just to look at examples and see how it's done. That's the easiest way to learn. There is a scripting syntax tab, which is would be just a new tab on your browser, where you can look for all the different things that are in there, and you can find it. So that's one thing you can do. Now, in experiments. Oh, and also what I should say is there is a library which is helpful to know. So if you go get from library, yeah, then you browse down a little bit, and you can just click here to get a list of all experiments in the library, and you can choose one. Say, for example, I don't know, the Navon task is very popular. Say, I want to see this, you can try it out, and you can copy that. If you want to use this experiment, well, let me then, I can just say Navon, and then I copy it to my own account. Let's see if it works. Actually, yeah, it works. I don't use it often, but then you have that experiment in your own account, and you can look at that. So you can go through the experiments and copy directly from it. By the way, just as a side point, I open a new browser tab now. If you go to the PsyToolkit website, note that there is a library of experiments, which is the same library, and you can, there are something like 25, 26 experiments in there. You can just browse through it, and you can choose one of these. These are common experiments that actually, these are almost all experiments that I used at some point. That's why they're on there. And you can choose one of those. You can also see how they works. By what I should say, if you are interested in memory, and this is something that's used a lot, I strongly recommend the Corsi block tapping task. Do you know the Corsi? Who knows the Corsi block tapping task? So yeah, so it is quite a nice task. I quickly just show it to you. In the Corsi block tapping task, you see some blocks on the screen, and you need to remember which. So you see up to 9. You will see 9 blocks. Some will light up in a sequence. Once you hear go, which you don't hear now because we don't have sound, I think, but you need to click the same blocks in the same sequence. And if you do that, for example, oh, so you see it, and I don't remember. I think you need to, something like this. Was that correct? I don't know. If it's not correct, you see a red face and so on. So this is an example of a good memory task. In any case, okay, so let's go back here to our example. Zoom in a little bit again. Let me see. Sure, it's still on there. Okay. So one of the first things to know is that you can have comments. Every line starting with a number sign is a comment. So actually, the computer doesn't need those. I can just delete them for the time being. Let's do that, and the code still works. Comments are useful, of course, because what happens with writing scripts is that no matter how smart you are, after a couple of weeks, you will completely have forgotten why you wrote in your script what you wrote. So that's why it's good to have sort of like ways to help you remember it. Now, inside Toolkit, often you have bitmaps, so images, and you need to tell the computer which images are in your experiment. That's often a good thing to start with. So that is called what I call the bitmaps section. So you say bitmaps, and in this experiment we have 5 different bitmaps. One bitmap is called instruction, which tells the participant what to do. That's actually a bitmap. I made it with Inkscape. A thank you message, a message that people see if they make a mistake, and then there's a left arrow and a right arrow. Now you might say, okay, what do these images actually look like? I'll show you quickly. There is at the bottom there is a view files. There you can see your images. So we have, for example, a right arrow. And you see here, right arrow, it is actually a PNG file. So PNG is a very popular image format. So JPEG, as you probably know, is used mostly for digital photographs. There's a reason for that. Technically, photographs, they are best done in JPEG. But for these sort of images, like simple drawings, PNG is actually the best one to use. You can delete the image by clicking on the red cross. You can download it on your local computer. You can rename it. I show you quickly the pictures. So I said there were 5 pictures. So there's the right arrow, a left arrow, a thank you message in English, in this case, in multiple languages. I have the instructions in 4 languages, just because this is the example survey, so I made this in multiple languages. It's, my fluency in Chinese allows me to write it. No, I didn't actually. I asked somebody. And then, like wrong message. So now you might say, well, this is all text. Well, what happens in computers is that all computers, they have different fonts on their computer system. So if you want to make sure that text really looks identical on all computers, it's quite safe to actually make an image, make a bitmap of it, and save it. So I use Inkscape for that, which I have on my computer. I don't know if I actually have it on this computer. I do. So I just quickly have an excursion to Inkscape. Inkscape is just a drawing program where it's really easy to make. So for example, if I want to make a little picture, like a rectangle, and some text on it, I can say hello. In Inkscape, you just can make the text really quickly, can give it a different color, put it on here. Like this is good. If I make this, it will look exactly the same on all computers. And then I can just export this as a bitmap in Inkscape. There's a little tutorial on how to use this software. It's free. I like free software. It's fantastic software. You can make really nice drawings. So that's Inkscape, with which I make all my stimuli. Now go back to the experiment. So I've explained the bitmap section now. Note that the PNG extension does not need to be given. So you just say, if you say instruction, PsyToolkit knows that there is a file instruction.png. So PNG is sort of like the default file format, but you can also upload JPEG files and so on if you want.
Also the vector-based graphics, right? So an SVG file?
Yeah, but actually, it doesn't use the vector-based format. The reason for that, again, is that fonts are never working, even though they say it does. So you see the same with PowerPoint, for example. If you have a PowerPoint presentation on one computer, it might look slightly different on another computer because the fonts slightly differ. This is a big problem. So that's why even there are 3 font types that are quite stable: Arial, Times, and typewriter or something like that. They work, but otherwise I think I would be quite careful if I want. They might stimuli look the same. Then also what's good to know that I indented everything here. So I've bit a section, and then I indented it. You don't need to, but it makes it more readable. Now, then I have a table, which is quite useful in PsyToolkit for defining your different experimental conditions. So in this experiment, we have, and I'll just move in a little bit, just to make it better to see. So if we look at this table here, now this looks complicated probably, but this is a table with 4 columns. So the first one is what we call a string, something between quotes, and that's just for humans to read. The computer does not further interpret this. Then we have a number that's actually the stimulus position. You don't need to know this, but just remember there's a number here, -200, the name of the stimulus, and then I have a number here, which actually I know that 1 is what we call in the assignment task a compatible stimulus, and there are incompatible stimuli. But what's important to remember here is that the table is for me a place to put the 4 experimental conditions. So 4 conditions, and in the assignment task, what you have, for example, you have an arrow. First of all, it's red or green, and it points to the left or the right. And sometimes if you see a left-pointing arrow, and it's really hard to respond with your right hand to it. So that's what this experiment is about. So, well, actually, what I could do, actually, I could show you this experiment before we actually, so that you know what it actually looks like before we even run this. So I compile it quickly. So before we talk about the script, let's me actually see what it looks like otherwise. So you get the instruction first. And then this actually, I should have done this. It says actually the instruction is in there. I didn't read. I need to press A or L. So if I see, red arrows are, so this is the right button. I press the L, okay. Press the A button because it's left, right. And if I make a mistake, let me make a mistake. It says wrong key. So that's what it looks like, right? So that is the task we are programming. So let me go back to the experiment editor. Okay. So the key thing now, the most important bit, the most difficult bit is writing what happens in one trial. We call the task, so it's called assignment task. And in the assignment task, we have a number of lines, and each line tells the computer what to do. The first line actually is very simple. It says, use this table that I just showed you. Those are the conditions of this experiment. And every time you do a trial, it will randomly choose one of these lines. So for example, it might randomly choose the first line, and then it will, for example, know that it needs to use this number -200, the image left arrow, so it knows that, okay? So, Now, in any case, okay, so also you need to tell which computer keyboard keys you want to use. In this experiment, I use only 2 keys, the A key and the L key, and I use them because A and L is quite nice. I don't know, in Hungarian keyboards, yeah, A here as well. So A is on the left side and L is on the right side. So that's quite useful because this experiment is very much about space. Then actually so far nothing really happened. Now the first thing that really happens for the participant is showing a rectangle. And this, this even looks a little bit complicated, I must say, because there are all these different numbers. So now show rectangle, that in itself is easy, right? So you show rectangle, okay, you understand that, show a rectangle. But then what I'll do, there are 1, 2, 3, 4, 5, 6, 7, 7 numbers. That looks complicated at first sight. I agree with that. This is where I think people can say, oh, just this is too difficult for me. Okay, I'm not going to know what that is, 7 numbers. I appreciate that. So in E prime, for example, you wouldn't have that problem. Do you know E prime, or is something that's quite popular, right? So you wouldn't have that problem that you need to know. But actually, so you can look it up in the documentation. What do these 7 numbers mean? But so the first 4, they are about the location and the size of the rectangle. So the first 0, 0, 0, 0 means that's the middle of the screen. So this means there's a rectangle that comes in the middle of the screen. And 10, 10, that is the width and the height. So 10 pixels width and height, that's quite a small, actually this is sort of like the fixation point. Then the last 3 numbers, they are just the color codes. So in computer science, there is sort of like a convention to code computer colors as 3 numbers. There's a red, green, blue system. So the first, they are usually so numbers between 0 and 255. That's just a convention. So 255 is the maximum level of red. 255 for the green channel, maximum green, and maximum blue. Together, this results in the color white. Okay, you have to know that. Now I agree, actually, I must say, that is somewhat confusing. Okay, so, yeah, you have a question?
Yeah, so here you don't use a bitmap for a rectangle, but there is a inbuilt something.
Oh, well, that's a good point, actually. Yeah, I could have used, of course, instead of actually drawing. Yeah.
But it's such a good thing. Like, do you have a circle?
Yeah, you can. There are certain basic shapes that you can draw. So a rectangle and a circle, and you can also draw text directly without using bitmaps. Because yeah, that's a good point actually. So if you find these numbers all too confusing, you could just use a bitmap because it's very easy and very simple to draw a bitmap in Inkscape. But if you once you get used to this idea, okay, so it is the position are the first 2, then the width, and then you have this sort of like funny color scheme. Now, I know that my students find this confusing, okay? If I tell this for the first time, this is always with computer things. When you hear it for the first time, you think, gee, how can I know this? But if you want to know white, for example, is 255, 255, 255, that is sort of like a standard thing. I might actually in the future keep that color coding, but add something else to, it would be more code, but then maybe just another line to say, draw everything in the color red. And then I already have that for text, but I might add that actually. Okay, so this draws this small rectangle. And then it says delay 200. And delay is a key command in PsyToolkit. Delay just means do nothing for 200 means 200 milliseconds. That's 1/5 of 1 second. Because 1 second, no, sorry. Yeah, no, it is. 1 second, of course, is 1,000 milliseconds. Again, that also my students, when I tell them for the first time, they get confused about it. It's a little bit confusing. Okay, 1,000 milliseconds. in a second. 200 is very short, of course. It's a fraction of a second. It's very quick. Yeah. So this is this short white rectangle. And let's go back actually to see what that actually looks like. Okay, so that quick rectangle, do we see that actually there? Yeah, there it was. So see, if you look at it, you very short, you see there, you see it right in the middle, you see this small white rectangle. That is actually the rectangle that we just drew, and it is on there for 200 milliseconds before an arrow is shown. So that is what we just have learned to code. Okay. So where we now? So we're here at this. So what we have done so far, we have drawn this small rectangle. Okay, that's 2 lines of code. Then I say clear 1. Now clear 1 means actually, clear means just remove a stimulus. And it says clear 1. That refers to the first stimulus in the task. That, there was only one stimulus so far. So you could also say clear -1. That just means create the last stimulus that you have drawn. Or say clear 1. Remove the first stimulus from the screen. That means you need to count the stimuli. You need to know which number they have. Or you can always just use clear -1, clear -2. Then again, there's a short delay of now only 50 milliseconds. And then we have, again, a complicated line. Now we show a bitmap. But then again, you have all these sort of like difficult things. I mean, again, if you see this for the first time, now remember this is comment, so you don't need to remember this, right? So let's remove that for a second. Let's just look at show bitmap. But then there are these numbers behind it. What does that mean? Well, again, I mean, this looks very cryptic, okay? So now what you should know is that to be honest with you, I don't even know why this 0 is here. To be honest, I don't actually know if that is necessary. It might not even be necessary. Show bitmap.
That means maybe it relates to the location, right?
No, I don't think so. I think you probably don't need it actually. Sorry, let me just make sure. I think I typed it as, oh no.
Maybe when you delete everything else.
Oh, incorrect number. Oh, sorry, no, there is, I just was not thinking, sorry. No, okay, now I know what it is. Sorry, I see that is how confusing code is that's why people have E prime. Because it is true that, you need to think a little bit about it. Okay, so what it means is, so show bitmap, the first one, is actually the image that you want to show, okay? And then the second and the third one this is the X position, left, right, where is it? Left, right on the screen. And the third one is the horizontal position. 0 means it's in the middle of the screen. So this one, these @3 and @2, they come from the table. So @3 is the third column of your table. So this means left arrow. So if the computer is if it shows this line from your table, it will take the third column, so that's left arrow. It will show a left arrow. That's the bitmap that it will show. And then here the @2 is the position, which is, for example, -200, which means left of the center. And the 0 means just that it's always in the middle of the screen horizontally. So it is the location, okay? So this is how you do it. Once that is shown on the screen, you say read key. Again, we use a parameter from the table, the fourth one. That is the key that you expect the participant to press. It's a 1 or a 2. It's like the first or the second key in this keys list. And read key, read maximally 5,000, wait maximally for 5 seconds. Now, the way this works is why it says read key, you know, read from the computer is told to read or get information from the keyboard. You need to tell the computer which key is the correct one. Is it the A number 1 or is it the L number 2, right? So the computer needs to know that. And because in different conditions you have a different key, somehow in the table you say which of the keys you expect the participant to press. So that's why it's 1 or 2. And that can vary from condition to condition. So that's how it works. Okay, so I can see, if you see this for the first time, this looks quite cryptic. If you do this regularly, it's actually not that difficult. The students that I have supervised in the last, my PhD students, they had no problems with writing these sort of scripts. But you have to have done this a couple of times to, remember, that's the way it works. This is the problem with computer coding. Yeah, initially, wow, looks super complicated. How can I possibly remember this? If you've done it for a week or so, then you say, I know. But you need to always do this again and again. So you see, even if I have not done it, I have not recently written these scripts due to teaching duties and so on. And then even I wonder, how does it work? So you need to work through it, okay? Then again, but then you have now already actually had most of the things that you need to know. Clear to, that means just cleared, after people have pressed the button, clear to just clears the second stimulus. So that was actually the arrow that was drawn. That is now removed from the screen. And now we have a few lines. They are the if lines. Only if something has happened, you do something. If the status is whether people press the right or the wrong button. If the status not equal, right, that is the computer sign for not equal. That's just how it is in computer science. Again, it's sort of like cryptic if you have never seen that before, but that is how computers work. If the status is not correct, I might actually in the future as well, I might sort of like write not for users. Maybe they find it easier. But it's computer language, so if the status is not correct, then show the bitmap called mistake. Now this is a very easy line, no coordinates given, so that means it shows it in the center of the screen, right, in the middle of the screen. Show bitmap mistake, delay 3000 means wait 3 seconds, and then clear stimulus 3, that is that stimulus. Then it says phi, then you want, what's that? Well, that's the opposite of if, right? That's if written the other way around. And that just is the end of this if block. See that these lines belong together. And the computer knows, if do this, if that happens, and then this is the end of that if-then situation. Again, I mean, that is sort of like some computer languages uses this if phi, that's just if is the opposite is phi. Okay, that's just something you need to know. Then at the end of the trial, wait another 500 milliseconds, and then something really important happens as well. You write to your output file the important information. In this case, one thing that you can save is standard in PsyToolkit, the name of the block. Then you can write the first parameter of the used table, so that is actually nice written out for people, so left stimulus, left response, red. So the table row, so that's the number of the condition, the key that was being pressed, the status, whether it was correct or incorrect. In PsyToolkit, that's a number between 1 and 3. So 1 is correct, 2 is wrong, 3 is too slow, and then the reaction time. So these are all the lines that you need. Now, I agree that at face value, this looks confusing. I think, if you see this for the next time, this is all sort of like cryptic computer language. If you think from the point of view of a student who has never seen this before, I appreciate that. So some people are allergic to programming and writing code themselves, so they would never do it, and I can appreciate that, although they can copy and paste these experiments from the website. But on the other hand, there are many students, in particular postgraduate students, like master students, PhD students, who find this not difficult to do. And also realize that we have only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 lines of code in which you have a whole experiment. If you would have done this in E prime, if I would have done this in E prime, I would have gotten a headache with drawing things and then don't know how to draw the things, and you have very little flexibility, especially if it comes to, okay, what if the participant makes a mistake? Then to have these sort of things, I never figured out how to do that in E prime. That's when I gave up on E prime, for example. Apparently, yeah, you can do this, but people who need to do an E prime experiment also spend a whole day on getting it to run. So it's not necessarily. The only thing I think with E prime is that you can drag and drop these things, or with Open Sesame, I think you can do this as well. Yeah. Yeah, but then you still have to program anyway, so then you still have to program them as well.
Depending on what you want.
All right, yeah.
Yeah, sometimes it's just required to have that additional flexibility.
Yeah, right. No, it is. Yeah, there is no such a thing as a free lunch, I think. You know, you just don't, nothing in life is really easy. The final thing is, so this describes what one trial looks like. Really important is the block. In a block, you say, okay, you tell basically, first you start with the instruction that in a block that is just not show bitmap. There's something like called a message, which just shows one bitmap and then waits until people press the keyboard. There is an option to do it with the mouse or with a touch on a touch screen, so you can use touch screen experiments as well where you don't need a keyboard. Very important is the task list. Task list is ended by the end command. Between that, you say all the things that you want to happen in one block. Here we have only one task. This task is called Simon, and you just say 20, which just means I want 20 trials, whether they make a mistake or not. There are ways to refine that, all sorts of ways you can say they must all be correct, or I want to have at least 50% correct trials. You can do that. And then at the end, you have message, thanks. So that is all. You can make far more complicated experiments. There are many examples on the website. The more, you can also, there are also simpler ways. You know, some experiments would even be simpler than this, where you don't have conditions, for example, where you don't have this table. So it all depends on what you want.
Question, the way you wrote it like this, will it just pick randomly 20 trials from this table? Because then the frequency of each condition might be a little bit different.
Might be different, yeah.
This is all before repeat.
Yeah, you can use that in order to, yeah, this is...
Sure, and the number of trials per condition will be presented. Right?
Yeah, right. This is a little bit an issue. I've had many discussions about this. So some people, I personally think if you say random, it should really be random. The problem is that, yeah, if it's random, it might be that it does the forced condition for 20 times. That chance is incredibly small. You know, I always play the lottery, for example. I realize how difficult it is even to get one number correct. But yeah, okay, so some people want somehow that every trial is done exactly the same number. You can do it, but I don't know. Again, I mean, it is less random, right? Because if there are different ways to and I might improve it a little bit more so that you can.
For example, with the go-no-go paradigm, you want for each block a certain percent of no-go trials, because it has been shown that otherwise you don't really induce.
Yeah, you can do that though, because for the no-go, so you would have a no task and a go task. And you would say exactly, for that, for example, that is very easy to do. In the no-go task, that's how I did it.
It's still random, because you have a set of trials, and you just have, in this table you have 80%.
Yeah, right, exactly.
20% no-go trials, and then you repeat it in a random fashion, but you make sure that
Yeah, it is. I think it is always a problem.
Blocks
Yeah, randomization is, I think, a really complicated thing in cognitive psychology. And one thing is that no matter how many options I would give, there is always some people say, "Oh yeah, but I want it this way." What you
depends on the situation.
Yeah, it depends on the situation. So, but what I recommend people to do, if you do any sort of experiment, certainly something like go, no go, but also this assignment task, what I recommend is to look whether one trial is repeated many times. Because a repeat trial is always easier. So here with PsyToolkit, you can have an option no repeat, where you don't get the exact repeat of the previous trial, because sort of like that. But then of course people also know then, people can be strategic about it. So okay, I know I will never get a repeat. So an alternative way that we do when in our research projects with task switching, we just, in the analysis, we take out repeat trials, which is commonly done, so that people cannot develop the strategy, so that they already know, oh yeah, it's not going to repeat. But yeah, it is an extra processing stage. So there is, there's some, because it really can make a difference in your analysis. Repeat trials are just easier for people to do. But if you really want it random, then it's nice that it is really unpredictable. It all depends also a little bit on how many trials you have, so there are many things to think about. Yeah, but it's a good question. Right, yeah. So are there any other specific questions right now about how this coding is working? Or is this... Yeah, right, yeah, go ahead, yeah.
Which I've been struggling with, not just with PsyToolkit in general. Whenever you present the stimulus and then it waits for
Yeah.
present
Yeah.
key line after the show bit, etc. So you press and then the stimulus
Yeah.
is gone from the screen. Now there can be some situation in which you want to fix the stimulus duration. Say,
Oh yeah.
for 150 milliseconds doesn't really matter because it's already gone before you.
Yeah.
can
Oh
actually
right.
press
Yeah.
it. You want to exclude fast responses anyway.
Yeah.
Because they don't really present any realistic response.
Yeah.
But what if you want stimulus presented for, let's say, half a second,
Yeah.
even longer, and you want this to be consistent while being able to record it?
Yeah. Right. Exactly.
What I currently do is that I do show a bitmap.
Yeah.
And then
Read key.
and
Yeah.
then as soon as someone presses,
Yeah.
for the remainder of the duration,
You have another
I
read
put it
key.
back.
Yeah.
So I think it's
You have another read key, right? You mean?
sorry?
You have another read key.
Okay, so there's a different way.
Oh, I see. Oh,
So what I currently do is I show bitmap.
Yeah.
And then there's this read key.
Yeah.
line.
Yeah.
So as soon
For
as someone
fi-
presses, it will disappear.
Yeah.
But I will prevent that from happening by immediately after this. read
Oh
key
yeah.
line.
No, that's not the way to do it. No. So the way to do it. Say for example, if you say I want to show a bitmap for 500 milliseconds, and no matter what, it has to disappear, and the people still need to be able to press the button, right? That's what you want.
Also in the time frame of the stimulus duration. So I want it. So
Oh.
even if it's on the screen, if someone presses, I want it to remain on the screen for a set duration.
All right, yeah.
500 milliseconds.
Well, why do you clear it then? Then just don't clear it. And then that sounds. So you just wanted the stimulus is always on the same time, right? Say it should be on for
500 milliseconds.
yeah, 500.
Irrespective of whether
Where
someone
it press, yeah.
or not.
Well, what you would do is, okay, in that case, I would do a read key. So you show the bitmap, yeah?
Yeah.
Then you do a read key 500, right?
No, but I want it.
Yeah, but then wait.
For not just for 500 milliseconds,
Yeah.
but for 2 seconds.
Yeah, and then say you do a read key 500, yeah? Then you clear the stimulus because that's what you want, right?
Yeah.
And then you do another read key for say 1500 milliseconds. And then you need to make sure that in between you check if people already pressed or not. There are several examples in that. I think I do it in the stop task, where you can have multiple read keys. Read key can be basically also a timer, and people don't realize it, that it can still record. Yeah. So
I kind of solved it, but it just didn't.
Right. Oh well. Tell me. Yeah. So there is a.
Solution, so
Yeah. It is.
I will send it.
Yeah.
and
Right.
you will
Okay.
also
Yeah.
see what I
Yeah.
mean,
I
and
can show you that example. Yeah.
I'm curious how to
Because it is.
better.
Yeah. Right. Yeah. Okay. Good. So that's a good question. Yeah. There's other specific coding questions that, or also about anything else. Wait.
I'm not sure what
Yeah.
is clear.
Oh, clear. Clear means just remove. That's the stimulus. Remove a stimulus from the screen. So clear means clear it. So when a stimulus disappears, actually that's just clear. You can also do clear screen, then everything from the whole screen becomes cleared, and the whole screen will be black.
But so when you say delay 3000, then it will not disappear immediately?
Yeah. You have to clear, you have to specifically say, okay, remove that stimulus from the screen, yeah. And you can use the number, because the computer, you need to somehow, because you can show the same stimulus 10 times on the screen, so you cannot say clear bitmap so and so from the screen, because it can be anywhere on the screen. So you need to say which instance, and the instances are just numerically coded.